Welcome back, statisticians and everybody out there in internet land. We're going to be continuing on in our journey through the course of statistics, and we're going to be talking about discrete probability distributions today. So in our book, it's over sections 5.1 and 5.2. You should have some pre-printed notes. What we hope you will be able to do is see how the random variables relate to the probability distributions and be able to distinguish between discrete and random variables that hopefully you remember from way back when we did a little activity to distinguish those two, and also to create a probability distribution for a random variable. They have a chart and we have a graph that we're going to be doing. So let's get rolling. Many decisions in business, insurance, other real-life situations are made by assigning probabilities to all possible outcomes pertaining to a situation and then evaluating the results. For example, if you're a salesperson that works on commission, you calculate your average sales and try to come up with how much income you will receive from the week. Even people who make business plans like to examine probability that they're going to have customers, and they look at growth and all that kind of thing. So there's a lot of applications for these probability problems. In this chapter, we're going to combine the methods that you've used already, descriptive statistics and those of probability, which was just the last chapter, and talk about probability distributions. Probability distributions describe what will probably happen instead of what actually did happen. They are theoretical, and you know life is not always a mathematical equation. So in order to fully understand probability distributions, we have to understand the concept of a random variable and be able to tell the difference between discrete and continuous variables. So we're going to talk about our discrete probability distributions first. This is what we've done so far, and I thought this was a good summary of what we've done. First off, conduct experiments in that, and we gather data, and then we put them in frequency distributions and different types of charts. Find the probability of each outcome, and then you can, this is what we're doing here, which is making a probability distribution. So let's get going. A variable is a characteristic or attribute that can assume different values, and a random variable is one of those that can be determined by chance. Discrete variables can be counted, like how many students in a class. Continuous variables are measured, like how tall is each student, because there's an interval of values. You know, you have 5.6 feet tall or whatever, so they can take on an interval of values. A probability distribution is a description that gives the probability for each value of the random variable, often expressed in the format of a graph, table, or formula. So let's look at this. This is what our table is going to look like. You're going to have a random variable, x, up here, and the probability of that variable, those values down here. This can be done vertically or horizontally. Our book does it horizontally. Yes, okay, no jokes there. Determine the sample space for the outcomes possible when you toss 3 coins. So the first thing when we're getting ready to do a probability distribution is find out what the probabilities are. So we're going to start out tossing 3 coins. So tails, 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 heads, heads, tails, 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 head, tail. These are all our possible outcomes. And I color-coded them for your entertainment. Purples are the tails and reds are the heads. And if we were trying to assign a variable, if we let x be our random variable for the number of heads, could have been the number of tails? Yes, but let's do the number of heads. In a sample space, when 3 coins are tossed, then x can be 0, 1, 2, or 3. So there's no heads in this trial. There's 1 head in this one, 1 here, 1 here, 2 here, 2 here, 2 here, and 3 here. So those are the possible values for the number of heads in each trial. Constructing a probability distribution, I just rewrote those so we can take a look at them. But if we're doing x on top, that's the number of heads we have, and the probability of each of those. So the number of heads we said was 0, 1, 2, 3. That goes on the top. Then we look at the probability of getting 0 heads. There's only 1 out of 8 possible tries, so 8 possibilities. So that's 1 out of 8. How many ones have just 1 head in them? There's 1, 2, 3. So that's going to be 3 out of 8. 2 heads are better than 1. 1, 2, 3. So that's also 3 out of 8. And 3 heads, it's only 1 out of 8. So couple things I want you to notice here. These are all less than 1, between 0 and 1. Probabilities cannot be negative and they cannot be bigger than 1. Also, if I added them all up, I would get 1. 1 plus 3 plus 3 plus 1 is 8. 8 over 8 is 1. That always has to be the case. So the requirements for a probability distribution are that all the probabilities sum up to 1, and that the probabilities are always between 0 and 1. You can have a probability that equals 0, you can have a probability that equals 1. Can't have one that's negative, and you can't have a probability that is greater than 1. So let's do the next one. Represent graphically the probability distribution that we just did. So here was the probability distribution that we did. We can express this graphically using a bar graph. So on your paper you've got a grid there. The probabilities go on the y-axis, and the values of the variable go on the x-axis along the bottom there. So these are our values of x, and our y is our probabilities. So I'll go ahead and label the axes, and then you just do a bar. And notice also that the 0 doesn't have to be where these two lines cross, where the x and y axis cross. You can set that over because we're talking probabilities of a certain value. So we're going to put 1/8. So we're going to just draw a little bar up to the 1/8 mark. 3/8, we draw one that's 3 times as long, another 3/8, and another 1/8. So there it is represented graphically, 2 different ways. So you can kind of analyze things visually, what is most likely to occur in a certain trial or experiment. Construct a probability distribution for rolling a single die. So what they mean by that is x is going to be the number on the face of the die. So what numbers are on the face of the die? 1, 2, 3, 4, 5, 6. And each of them is equally likely. You have 1 out of 6, 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 1 out of 6 for the probability distribution, theoretically. And if you notice, they'd all add up to 1. That's all there is to it. Next one. During the summer month, a rental agency keeps track of the number of chainsaws it rents each day during a period of 90 days. So they're wanting to say, is there any patterns? What's most probable? So in order to do a probability distribution, let's figure out what the probabilities are first. And probabilities, of course, can be expressed as fractions or decimals. So the probability of 0 days is 45 out of 90, which gives us 0.50. Probability of 1 day is 30 out of 90, which is 0.33. I'm just rounding off at the hundredth because that's where percentages round off. Probability of 2 days is 15 out of 90, which is 0.17 approximately. And then if we go to do our little table, we'll have the number of saws on the top and then our probabilities on the bottom. That's it. Then we just have to graph them. Remember, this would go along our x-axis, this would go along our y-axis. So what it's going to look like is, I'm doing 0, 1, 2 here, and up the side 0.1, 2, 3, 4, 5. And we're doing little bars. They do little kind of just vertical marks. So first one, probability of 0 was 0.5, so our bar goes up to 0.5. And then it goes to 0.33, so you just kind of approximate that, and then 0.17. So, and these were the number of saws. It's always a good idea to label your axes. What do we got next? Determine whether each distribution is a probability distribution. If it's not, explain why not. 2 things you've got to check for are the probabilities between 0 and 1. In this case, they all are because they're all 1/5. Do they sum to 1? Oh yeah, buddy. So this is a probability distribution. Let's look at the next one. Are the probabilities all between 0 and 1? No. This one's a negative one. This one's 1.5. So there's 2 that are off. Do they sum up to 1? Yes, but we don't care because if it doesn't have it both, it is not 1. So all probabilities are not between 0 and 1. Even though they sum to 1, this is not a probability distribution. All right, I want you to do the last 2 on your notes, and I will check them as part of your independent part of the note. So hopefully you know how to construct a probability distribution chart and graph it. I will see you later.